In section 8.5, we're going to be using factoring to solve polynomial equations. And the basis for this is called the zero factor property. That property says that if a times b is equal to 0, then a is equal to 0 or b is equal to 0. The only way to multiply to 0 is if you're multiplying by 0, if either a or b is 0. So we're going to use this to solve a polynomial equation. First, set the equation equal to 0, then factor the polynomial. Now you've got a product equal to 0, and we know the only way for that product to be 0 is if either of the factors is equal to 0. Let's look at example 1. I'm going to rearrange this so that it's equal to 0, so we're going to subtract the 7x over and add the 10 over. That'll give us x squared minus 7x plus 10 equals 0. Now I need to factor this so that I have a product. I've got a positive 10 I want to break up, and I know that I need two of the same to get a positive, and they need to both be negative to get a negative 7. So we're going to try negative 5 and negative 2, and that does in fact add to negative 7. So this polynomial will factor into x minus 5 times x minus 2, and it's equal to 0. The zero factor property says that the only way for this product to be 0 is if either x minus 5 is equal to 0 or x minus 2 is equal to 0. If either of these things happens, the equation is equal to 0, so it's true. So I solve each of these, add 5 to both sides. The first solution is x equals 5. And the second solution, if I add 2 to both sides, is x equals 2. So there are two answers to this equation. The equation is true for both x equals 5 and x equals 2. Let's try again in part B. I'm going to go ahead and start by distributing. This is going to give me 3x squared plus 2x equals 8, or if I subtract 8 from both sides, I'll have the equation equal to 0. Now I need to refactor the entire thing so that I have a product equal to 0. This has a coefficient of 3 in front of the x squared, so we're going to multiply the first times the last. We're going to get ourselves a negative 24. We're going to try to factor that negative 24 into two numbers that are going to add to a positive 2. Since the 24 is negative, I know I need one positive and one negative. The larger positive, since the 2 is positive. So if I try 8 minus 3, that's going to give us 5, so that's not going to work. Or 6 minus 4, that'll give us 2, so that one is going to work. Now, since this is a coefficient, 3 in front of the x squared, I'm not ready to jump right into factoring like I did when the x squared was by itself. Instead, we're going to separate this and use grouping. So 3x squared, separate your 2x into plus 6x minus 4x, then bring down the minus 8, and factor by grouping, first 2 and second 2. The first two have a 3 and an x in common. If you pull that out, you're left with x plus 2. And the second two terms can both be divided by negative 4. If you pull the negative 4 out, you can be left with x, and negative 8 divided by negative 4 is positive 2. Factoring is not quite finished, but notice that both groups have the binomial term x plus 2 in common, so you can factor that out, and you'll be left with 3x minus 4. And finally, it's factored and set equal to 0. Since I have a product equal to 0, using the zero factor property, we can separate the product and say that x plus 2 is equal to 0, or 3x minus 4 is equal to 0, and we'll solve each of these. If I subtract 2 from both sides, the first equation gives me x equals negative 2. If I add 4 to both sides, I'm going to get 3x equals 4, and then divide both sides by 3, we get x is equal to 4/3. So again, I have two answers, x equals negative 2 and x equals 4/3. Let's look at part C. We know that we need everything to equal 0, so let's subtract the 5x and subtract the 20 off. So I'm going to have 2x cubed plus 5x squared minus 8x, when I subtract that off, minus 20 equals 0. Let's factor. Group, since there are 4 terms, I must group to factor. The first group has x squared in common. Factor the x squared out, you're left with 2x plus 5. And the second group can both be divided by negative 4. If you divide out negative 4, you're left with 2x and a positive 5. Now you're not quite factored yet, but you can see that binomial, 2x plus 5, can be factored out. And that'll leave you with x squared minus 4. Now this is a product equal to 0, but this product is not yet completely factored. Since x squared minus 4 is a difference of squares, I can factor that again. So let's keep factoring. We've got 2x plus 5 times the difference of squares here will factor into binomial conjugates, x plus 2 times x minus 2. So I have three things multiplied to 0. I'm going to set each of these three things equal to 0. So I'll have 2x plus 5 equals 0. I'll have x plus 2 equals 0. And I'll have x minus 2 equals 0. So I'm going to get three answers to this equation. If I subtract 5 from both sides, 2x would be equal to negative 5. Then divide by 2. One of your answers is x equals negative 5 halves. Subtract 2 from both sides. Another of your answers is x equals negative 2. And add 2 to both sides. Another of your answers is x equals positive 2. Let's look at part D. Part D starts with fractions where the common denominator is 6. So I'm going to multiply every single piece by 6 to clear the fractions. When I multiply the first piece by 6, 6 goes into 6 one time, so I'm going to get 1x squared. In the second fraction, 3 goes into 6 twice, so I'm going to get 2 times 4, or 8x. 6 times 5 is 30, and equals 6 times 3 is 18. It's nice to clear the fractions first so that I can work in an equation that has only integer values. To get this equal to 0, we're going to subtract the 18 off of both sides. So we're going to have x squared plus 8x plus 12 equals 0. And we need to factor this. Let's take our 12. Our 12 is positive, and so is the 8. So we know we need two positive factors. 12 is 4 times 3. 4 plus 3 is 7, so that's not going to work. 12 is also 6 times 2, and 6 plus 2 is 8. So this one will work. The first choice we chose did not work. Keep on trying until you get it factored. So this factors into x plus 6 times x plus 2 equals 0. Set each factor equal to 0. X plus 6 equals 0, or x plus 2 equals 0. The answer from the first one, if you subtract 6 from both sides, is going to be x equals negative 6. And from the second, subtract 2 from both sides, x equals negative 2. In example 2, I'm going to solve some more of these. This equation is factored, however, it's not equal to 0, so we need to unfactor it, get it equal to 0, and then refactor it. So let's distribute. If I distribute, I'm going to get 8x squared minus 12x minus 2x plus 3 equals 3. And then we're going to combine like terms and get this equal to 0. So 8x squared minus 14x plus 3, and we're going to subtract 3 from both sides to get this equal to 0. So we're going to have equals 0 since the 3's are going to cancel out. Once I get it equal to 0, it's a whole new equation. It's going to factor a little bit differently this time. When I factor, there's only two terms. There's something in common. I can divide these both by 2 and x. That'll leave us with 4x minus 7 equals 0. The first part of the factorization is 2x. So 2x equals 0 is one of my options. The second part of the factoring is 4x minus 7. So 4x minus 7 equals 0 is the other option. If 2x is equal to 0, divide both sides by 2. That gives you x equals 0. And if you add 7 to both sides, that would be 4x equals 7. Divide by 4. The other answer is x equals 7 divided by 4. Let's look at part B. Once again, this is not equal to 0, so we need to distribute, simplify, rearrange. If I distribute, I'm going to have 4w squared minus 12w equals w squared plus 4w plus 12. Let's subtract the w squared off. 4w squared minus w squared is going to give you 3w squared. Negative 12w minus 4w is going to give you negative 16w if you subtract the 4 from both sides. And if you subtract negative 12 from both sides, you'll get minus 12 equals 0. Now this needs to be refactored. Let's look at the first term has a 3w squared. The last term is negative 12. So if you multiply those together, you're going to get negative 36. It's negative, so the factors are going to have to be one positive and one negative with a larger negative to get a negative 16. 36 is 3 times 12. So if you have negative 12 and a positive 3, that would add to a negative 9. So that one doesn't work. 36 is also 18 times 2. So if you had a negative 18 and a positive 2, that would add up to negative 16. So that pair is going to work to get the correct term in the middle. So let's separate that. It's going to be 3w squared minus 18w plus 2w minus 12 equals 0. And 4 terms now, so we're going to group. The first two have 3 and w in common. If you factor that out, you're going to be left with w minus 6. And the second two terms have a 2 in common. If you factor the 2 out, you're going to be left with w minus 6. It's almost factored. They have a binomial in common, the w minus 6. Factor that out, and the first term is going to give you a 3w, plus the second term is going to give you the 2. Now it's completely factored, so we're ready to set each factor equal to 0. If w minus 6 is equal to 0, you're going to add 6 to both sides and get w equals 6. And if 3w plus 2 is equal to 0, you're going to subtract 2 from both sides, get 3w equals negative 2, and divide both sides by 3. You're going to get w equals negative 2 thirds. So those are my two solutions. We've already seen that we can solve any equation using a calculator by graphing both left and right hand sides of the equation and finding the intersection. In example 3, we're going to do just that. We're going to solve these by graphing. So I'm going to graph the right-hand side and the left-hand side. Now notice that examples A and B here are the same two problems that we had in examples A and B above. So we're going to get the same solutions. For the first equation, I need to graph 4x minus 1 times 2x minus 3 in the first equation, and it was equal to 3, so 3 is going to be my second equation. I want to graph these in a standard window, and you can see that the parabola from the first side intersects the line y equals 3 from the second side in two places, so there are two values where they intersect. It does look like the answers are 0, and it was supposed to be 7/4. 7/4 is almost 2. Now, I can't tell just from looking at the calculator that that's 7/4, but let's go ahead and verify it. So if I use second calculate, option 5 for the intersection, the first curve is the left-hand side, hit enter. The second curve is the right-hand side, hit enter. Let's guess. Let's get the first one. So you can see the intersection is at the ordered pair 0, 3, x value 0. And let's do it again to get the second one. Second, calculate, option 5 for intersect. Again, first curve, second curve, but this time we're going to move the cursor over to the right before we hit guess, and it's going to find us the second ordered pair. 1.75, which is the fraction 7/4, 3. So the second x value is 1.75. So I have the two solutions, 0 and 1.75 or 7/4. Let's do the same thing in part B. The left-hand side of the equation, 4x minus 3, and the right-hand side of the equation, x squared plus 4x plus 12, will be entered in separate equations. We're going to hit graph. And if you're in the standard viewing window, you're going to see something like this. The second parabola is a bit higher, so you can't actually see where they intersect. We're going to need to change our window. I'm going to increase the value of y maximum so the graph is higher. Let's try a value of 30 to start. With the value of 30, I can see one of the intersections, but I still cannot see the other, so we're going to make it a little bit higher and try again. I don't want to miss, so I'm going to try 90. Now we can see both of the intersections. Let's go ahead and find the first one. Second, calc, option 5 for intersect. The first curve, you can see the left-hand side there. Second curve, you can see the right-hand side. And guess, we're already closer to the first one, so let's hit enter. The first one is negative 0.66 or negative 2/3. We can verify that negative 2/3 was the first of the two values. And the second value, let's go ahead and find that one. Second, calculate the intersection. That's our first curve, so hit enter. That's our second curve, so hit enter. Then we need to move the cursor over to closer to the second. Once your cursor is closer to the second intersection, hit enter. And it finds that it is x equals 6, as we knew that it was since we had already solved that equation. So once again, we found the same two values in the calculator that we had found by hand. The calculator wasn't as precise though. It gave us this repeating decimal, so we really do want to represent that as negative 2/3, or x equals 6 is the other solution. Note that when one side of the equation is 0, the graph of that side is y equals 0, and y equals 0 is the x-axis, so the intersection points that you're really finding are the x-intercepts, or the zeros. In example 4, we want to solve the equation x squared minus 2x minus 8 equals 0 by hand and by graphing. Solve it by hand first. This equation is factorable. If you take negative 8, since it's negative, you want one positive and one negative. Let's break that into negative 4 and a positive 2, which add to negative 2. So it's going to work for factoring here. This will be x minus 4 times x plus 2 equals 0. So either x minus 4 is equal to 0, or x plus 2 is equal to 0. If x minus 4 is equal to 0 and you add 4 to both sides, you'll get x equals 4. If x minus 2 equals 0 and you subtract 2 from both sides, you'll get x equals negative 2. So those are my two solutions. Let's also solve this by graphing and talk about the relationship on the graph here. If I want to solve this by graphing, I'm going to enter the equation in the y equals menu. I don't need to enter 0 since I know that's already on my graph as the x-axis. Enter the equation into the y equals menu, then hit graph. Your graph should show up. Now you can see the two zeros. You can visually see that they look like negative 2 and 4. Let's go ahead and find them in the calculator. Second, to calculate, we're looking for not an intersection this time since we did not enter two curves, but the zeros. The zeros are the x-intercepts. Let's click on option 2. Now, when I'm looking for zeros, the questions asked are left bound and right bound. So we need to move the cursor to the left of the first zero, then to the right of the first. Once your cursor is on the left, hit enter, then move it back a couple spots to the right and hit enter, then just go into the middle and hit guess. You can see that the first zero is in fact negative 2. Let's try the second one as well. Second, calculate the 0, option 2. Move the cursor so that you're to the left of the second 0. Hit enter, and then move it a little bit further so that you're on the right. Hit enter, and enter again for the guess. You can see that one is in fact 4. So from the graph, you can come to the same two conclusions. These are the zeros, the places where the graph is equal to 0. In example 5, I want to find the x-intercepts of this function by hand. X-intercepts are places where the equation is equal to 0. We're going to verify by including a graph. So if I want this equation equal to 0, I'm looking to solve 4x cubed minus 12x squared minus x plus 3 equals 0. And since there are 4 terms, I'm going to factor by grouping. The first two terms can both be divided by 4 and x squared. So if I factor 4x squared out, I'm going to be left with x minus 3. The second two terms start with a negative. I'm going to factor a negative out. There's nothing in common besides 1, so it's going to be a negative 1 I divide out. If I divide out negative 1, I'm going to be left with x, and positive 3 divided by negative 1 is negative 3. Now, both have the binomial x minus 3 in common, so we'll factor into x minus 3 times 4x squared minus 1 equals 0. I'm not done factoring yet because I still have a quadratic here that can be factored. It's the difference of squares. This is x minus 3 times my binomial conjugates of 2x plus 1 and 2x minus 1 equals 0. Now we have 3 parts of a product all equal to 0. So we're going to have x minus 3 equals 0, 2x plus 1 equals 0, and 2x minus 1 equals 0. Adding the 3 over is going to give me x equals 3 for my first answer. Next, if I subtract the 1, I'll get 2x equals negative 1, or divide by 2, x equals negative 1/2. And if I add 1 to both sides, I'm going to get 2x equals positive 1. Dividing both sides by 2 gives me positive 1/2. So I have 3 answers. Now these are my 3 x values, but be careful because I wasn't just asked for zeros or x values. I'm asked for x-intercepts. And x-intercepts will be full ordered pairs. So my actual solutions here are the ordered pairs 3, 0, negative 1/2, 0, and 1/2, 0. Intercepts should always be written as ordered pairs. Now I want to also verify this by graphing, so we're going to take this equation and graph it and look for the zeros. Back to our y equals menu, clear it, and enter the new equation. Once your new equation has been typed in, click the graph button. And when that shows up, you can see your 3 zeros. They do indeed look like -1/2, +1/2, and 3. You can find them again by using the zeros button, option 2. And let's just find one of them. Let's go to the left of it, hit enter, then go to the right of it, hit enter. We're going to verify that this one is -1/2. So the first one is -1/2. You can use the same process in the other two to identify them. So as you draw your sketch, you can draw the 3 x-intercepts in there at -1/2, 0, 1/2, 0, and 3, 0. And that's the end of this section.